Alright, so in this section we go over 4.3 quadratic functions and their properties. So in the previous section we went over quadratic functions and graphing them, no, not quadratic, but linear functions and graphing them using their properties. Now in this case we're going to look at quadratic functions and the properties related to them and graphing using those properties, as opposed to previous chapter in which we graph using transformation. I'm going to go over one of these examples by transformations, and then we're going to move to properties. Okay, so quadratic functions, well, they are very similar to quadratic equations if you look at the form ax squared plus bx plus c. But the difference here, we have the f of x notation, and a, b, and c can be any number, with the caveat here that we cannot have a to be 0, because if a equals 0, this whole term goes to 0, and then, well, we're going to have a linear function. Okay, so how do we graph using transformations? Well, we're given a polynomial form of the quadratic equation. So the key here is to write ax squared plus bx plus c and turn that into some kind of ax minus h squared plus k, which is the vertex form. Okay, and to do this we will be in the need of completing the square. So we have this example right here, f of x equals 2x squared plus 8x plus 5, using transformation, not plotting points. Okay, so the first thing we do here, I need to turn this polynomial into this form, into the vertex form. Okay, so we call it vertex form because the vertex, it's located at h with the opposite sign and k with the same sign. So in order to complete the square, I'm going to factor out the 2 from the first two terms. Actually, we will factor out the leading coefficient from the first two terms. So in this case, I'm going to have this 2 times x squared plus 4x, and leave the constant term alone. Now, in order to have something like x minus h squared, inside of the parentheses I need to have a perfect square trinomial, but in this case I have a binomial only, not a trinomial. So in order to turn it into a trinomial, I need to add a magical mystery number, which is the number that we divide by 2, which is the middle coefficient, divided by 2, and then square. Okay, so I'm going to use different colors just to show you how is this going to be managed. Plus 4x. So I'm going to add some number. Okay. But notice this number at the end will be multiplied by 2. So I'm still going to be left with this 5. But in this case, notice I'm adding a number, but this number I add is being multiplied by 2. So in an expression, in order to keep the integrity of the expression, if I add a number, then I have to do the same, which is subtract the same number as well. Subtract 2 times whatever number we get. So in this case, the number we do is, the number we are going to add here is 4 divided by 2 and then square, which is 2 squared, which equals 4. So add 4 and add 4. Now to turn this into, this is already a perfect square trinomial. So that's 2 times x plus 2 quantity squared, and then plus 5 minus 2 times 4, which is 8, which reduces at the end 2 times x plus 2 squared. 5 minus 8, that's going to be negative 3. All right. So we are going to describe these transformations using words. So in words, so we have f of x equals x squared shifted three units down, 2 units to the left, and in this case, if we go back to our summary that we did in the previous chapter, so in this case we have a vertical scaling, right? We have a vertical scaling. Vertically scaled by a factor of 2. Okay, so I'm going to take only 3 points. So I'm going to graph the original parabola, which is y equals x, f of x equals x squared. The origin, negative 1, 1, and 2, 4, negative 2, 4. And I'm going to draw the parabola like this. Okay. And then from there, I'm going to do 3 operations. So I'm going to take only 3 points this time. So the point negative 1, 1, 0, 0, and 1, 1. So I'm going to do the shifting 2 units to the left. So when we do that, we when we shift 3 units to the left, we subtract 2 units to the x's only, to the x values of the given points to get negative 3, 1, negative 2, 0, and negative 1, 0. Now I'm going to do the shifting 3 units down. In order to do that, we subtract 3 to the y values to get x's remain the same. And 1 minus 3, that's a negative 2. Negative 2, 0 minus 3, that's negative 3. And negative 1, comma. Wait a minute, it looks like I didn't. Negative, oh, never mind. Negative 1, negative 3. Wait, no, this was supposed to be a 1. And yes, negative 1, so 1 minus 3 is negative 2. Okay. And then from there, to get the last shifting, I'm going to, in this case it's not a shifting, it's vertically scaled by a factor of 2. To do that, we multiply all the y's by 2. So times 2. No, wait a minute, we don't multiply. Do we multiply? Yes, we multiply by 2. So the y is going to multiply by 2 times 2 times 2. Right, so we get negative 3, negative 4, negative 2, negative 6, and negative 1, negative 4. And we are going to plot these points in our graph right here. So -3, -4, and then -2, -6. I'm afraid I'm gonna go off the grid here, and -1, -4. Okay, so and that's my shifted graph. Okay, so this is going to be our new graph. So this is how we do it using transformations. Now looking at properties, which is going to be a connection with many other things that we have done before. So first of all, let's review all the properties of a quadratic function. So consider the two case scenarios in which we have the graph of a quadratic function. In this case, we have the parabola that opens up and the parabola that opens down. So the vertex, it's going to be given by the coordinate h comma k, and when it's when the equation is given in the f of x equals ax squared plus bx plus c, we cannot just get hk from the equation like we did before, so we need to find the x coordinate by using the vertex formula. So in this case, if you multiply minus b and divide by 2 times the quantity a, that's going to give you the h value of the vertex. And then to get to k, plug in whatever number you get here in the original function. So we're gonna look at examples that will be in which you will see this in action. The axis of symmetry, it's an imaginary line in which the x coordinate of the vertex is given by the x coordinate or x value of the vertex. That's how we get the axis of symmetry. Concavity, well, this will be either concave up or concave down. How are we going to know when it's going to be concave up and concave down by just looking at the equation? Well, this graph, the one that opens up, is concave up, and that happens when a is a positive number, when the leading term, when the leading coefficient is positive, and it's concave down, that is a parabola opening upside down, when the leading coefficient is negative, that is a is a number less than 0. Are we going to have a max or a min? So minimum and maximum, that occurs when a is a negative number. I mean, it's a positive number, because when it's a positive number, it opens up. But when it opens up, look at this, we have a minimum. Otherwise, we have a maximum when a is less than 0, or when a is a negative number, the parabola opens down, and now we have a maximum point. To get the x and y intercepts, I think we have done a lot of this in the previous chapters. So for x-intercept, set y equals to 0 and solve for x. And for the y-intercept with its counterpart, set x equal to 0, solve for y. Domain and range. Alright, so for the domain of quadratic functions, these are going to be all real numbers. I'm going to use interval notation in this case. And set notation, for set notation I will do x such that x belongs to the set of all real numbers, you know, the fancy form. Now range. For the range, I'm going to divide this into two cases. So if A is positive, okay, if A is positive, that is going to be the parabola that opens up. Okay, so HK is going to be our this the vertex, and I'm gonna have here let me do a Cartesian plane for this. Okay, so the range in this case is gonna go from the lowest point of the parabola in the y direction, that is from K, and all the way up. So from K, including K, all the way to infinity. And using said notation, y such that y is greater than or equal K. And if A is negative, that is, we have an upside down parabola, look what's going to happen. Now again, we scan the graph from bottom to top. It comes from negative infinity and it stops here at the value of K. Okay, so in this case, negative infinity to K, and y such that y is less than or equal to K. A lot of symbols here and a lot of letters, but when we see this in action in the next examples, it's going to make more sense. Okay, so let's have a look at our first example. So consider the quadratic function x minus 4x equals to x squared minus 4x minus 5. Okay, so we are going to identify A, B, and C. In this case, A equals 1, B equals to negative 4, and C equals to negative 5. Will this parabola open up or down? In this case, it will open up. Are we going to have a max or a min? In this case, since the parabola opens up, we are going to have a minimum. And consequently, this is going to be concave up. How do we know our reasoning for B and C? That's because A is greater than 0, because A is positive. Now let's determine the vertex of the parabola. So we are going to use the vertex formula, which is negative B over 2A, and in this case minus B, which is minus negative 4, be careful with the signs, divided by 2 times A, which is 1. So we're going to have negative times negative equals positive, 4 over 2, which equals 2. So that's going to be, okay, let me write down vertex. So far we have the x value of the vertex. We need to get the y value of the vertex. How do we get it? By plugging in to the original function. So f of 2 equals 2 squared minus 4 times 2 and minus 5. And if we simplify this, we should get a negative 9. Okay, so the vertex will be at 2 comma negative 9. Okay, determine the axis of symmetry. Where is this axis of symmetry coming from? In this case, is the x value of the vertex. Okay, it's the x value of the vertex. Okay, and it has to be written as an equation, not just as a number. Okay, now let's see. Find the intercepts. To find the intercepts, what do we do? Set the x-intercepts, set y equal to 0 and solve for x. In other words, set the function equals to 0 and solve for x. And try to do the easiest as possible. Hopefully this is factorable. In fact, it is nicely factorable. So factors of negative 5 that add up to 1. So we're going to have plus 1 and negative 5. because 1 minus 5 is negative 4 and 1 times negative 5 is negative 5. Using the zero product property, we get x plus 1 equals the 0 and x minus 5 equals the 0. That is, x equals negative 1 and x equals 5. So those are the x values. However, keep in mind that the intercepts are meant to be expressed as ordered pairs. One in which negative 1 comma 0 and the other one 5 comma 0. Let's find the y-intercept. For the y-intercept, now we plug in f of 0, 0 squared, minus 4 times 0, minus 5, and in this case we get negative 5. That is the y-intercept is 0 comma negative 5. Okay. Write the equation in vertex form. That is, go from polynomial form, that is ax squared plus bx plus c, turn that into ax minus h squared plus k. That's what we're going to do here. So I'm going to have f of x equals to x squared. Let me rewrite the function first. So in this case, in the first example we did, I factor out the leading coefficient, but in this case the leading coefficient, if you notice, is a 1. So this is what I'm going to do. I'm going to add some magic number. Remember that magic number we added? So I need to add some number, and then I'm going to minus 5 from the original function. Because I'm adding a number, in order to keep it the same, I'm going to subtract that number. What is that number that we add and subtract? So this is the leading coefficient, which is 4 times 1/2 and then squared. So 4 divided by 2 is 2 squared, which equals 4. 4 and 4. Alright, so in this case, I'm going to write this, I'm going to enclose this as a perfect square trinomial. When I factor it, I get x minus 2 squared, and negative 5 minus 4 equals, minus 9. Now from here, the vertex is, change the sign to the 2 and keep the sign of the 9. 2 negative 9, isn't it the same as what we got above here? Using the vertex formula, you should get the same. For some reason, if for some reason you get two different answers, double check your work. Alright, let's see what's next. On the next page, we are going to use all the information that we got from the previous parts to graph this parabola. Alright, or to graph this quadratic function. So number 1, I'm going to graph the vertex, which we said it was with 2 comma negative 9. Okay, so in this case it looks like the grid goes over, so 8 and a 9. So 2 comma negative 9, and then we have two x-intercepts, negative 1 0, 5 comma 0, and then we have a y-intercept, which is 0 negative 5, 0 negative 5. Okay, and then I'm going to add another symmetry point here, alright, actually here, and I'm going to connect the dots. Whoops, it didn't come out perfectly. You should have touched the point right here, but for some reason it didn't. Now I'm going to draw the axis of symmetry using a dashed line. That dashed line is going to go like this. It's not a solid line, it's a dashed line, which indicates the symmetry of this function, of this parabola. Okay, And so we have the intercepts, one intercept, the other intercept, x-intercept, the y-intercept, and the vertex. Alright, so now let's state the domain and the range. So for domain, I guess we already got that. All real numbers, negative infinity to infinity, or fancy notation x such that x belongs to the set of all real numbers. For the range, okay, so in this case the range is going to go from the lowest point, which in this case is 2, -9. It's going to go from -9 all the way up to infinity. See how this goes up all forever? So the range is going to go from -9 to infinity using interval notation, and using fancy set notation, y is greater than or equal -9. Now we need to state in which the intervals in which the function is increasing and decreasing. Well, decreasing and increasing. Okay, if we look at the behavior of this graph, notice it's decreasing, coming from -infinity, and then at the vertex it gets to the vertex, to the x value of the vertex, and then increases again. So in this case it's going to come from -infinity to the x value of the vertex, which in this case it's x equals 2, without including that, because at exactly at 2 is neither increasing nor increasing. It's actually flat at that point, and then it's increasing from 2 to infinity. Okay, let's do a couple more of examples involving this graphing quadratic functions using its properties. So we have example 2, which is 4x squared minus 4x plus 3. Alright, so what are we going to get here? So we're going to do the same. We're going to identify our values of a, b, and c, so we can refer to them each time we are doing some of the calculations, like the vertex formula and all that. So for -4 and -3. Will this parabola open up or down? I claim it's going to be up because a is positive. Therefore, it's going to have a minimum, and it's going to be concave up. How do we know the answers from B and C? Because a is a positive number. A is greater than 0. Let's determine the vertex of this parabola. So x equals minus b over 2a, which equals minus -4 divided by 2 times 4. So in this case, careful, so it's going to be negative. So negative is positive, and see how the 4's go away here, and we are left with 1/2. Actually, positive 1/2. Now let's plug this in the graphing calculator to get the y value, f of 1/2. So I'm gonna have 4 times 1/2 quantity squared minus 4 times 1/2 minus 3. So 4 times 1/2 is gonna give us -2, and then when I square 1/2, I get 1/4 times this 4. See how the 4's go away? So I'm going to have 1 minus 2 minus 3, which in this case is going to be -4. So the vertex is -1/2 -4. Right, so we're starting to get not nicest numbers, all right, but you will see how it works when we graph this. So determine the axis of symmetry. Again, that comes from, it's an equation and comes from the x value of the vertex. Okay. Find the x-intercept. What do? Set the function for x squared minus 4x minus 3, set it equal to 0 and solve. In this case, well, we need to use the diamond method to factor this equation, to solve this equation by factoring 4 times a negative 3, that's a negative 12, and bring down the middle coefficient, which is negative 4. So we're going to get the following. We get factors of negative 12 that add up to negative 4. So that's going to be 2 and negative 6. Okay, so we're going to get this. We split the middle term into 2x and minus 6x. The other two terms, we just bring them down. And then in this case, because we have 4 terms, we're going to proceed by factoring by grouping. So factor out 2x in the first group, and we're going to be left with 2x plus 1. And then factor out a negative 3 to get a 2x plus 1. And then the next GCF will be 2x minus 1 and 2x minus 3. Those are going to be our factors. So on the one hand, we're going to have this one factor. Wait a minute, this is 2x plus 1, not 2x minus 1. And from here, we're going to get x equals negative 1/2. And here we get x equals 3/2. So we have two x-intercepts. Getting the x-intercepts, we get negative 1/2 comma 0 and 3/2 comma 0. Using approximations to decimal, well, in this case you might want to write this as negative 0.5 comma 0 and 1.5 comma 0. However, you will need to pay attention to what the homework is asking you to type in when you do it in MyMathLab. Are you looking for decimals or reduced fractions? So that's something you need to let me add a star here. So careful with the required answer formats. So sometimes, again, they might ask you for decimals, or sometimes they might ask you for reduced fractions. So now let's find the y-intercept. To get that, we evaluate the original function at x equals 0. That is, set x equals 0, solve for y. So that's 4 times 0 squared minus 4 times 0 minus 3. So f of 0 equals negative 3. So the y-intercept, it's going to be negative 3, or actually 0, comma negative 3. Alright, write the given equation in vertex form. So completing the square, again, f of x equals 4x squared minus 4x minus 3, and I'm going to do the factoring of the leading coefficient from the first two terms. That is, I'm going to factor out the 4, and I'm going to be left with x squared minus x minus 3. And then inside of the parentheses, I'm going to introduce a number that helps us complete the square. So x squared minus x, all right, x squared and this is going to be plus some number, and then in this case minus 3, and then I'm going to subtract Notice this number I add inside of the parentheses is going to get multiplied by 4. So in this case, I need to subtract 4 times the same number 4 times. Now, what is going to be that number? So in this case, n, it's going to be -1. The number is 1. 1 times a half, quantity squared, and in this case is 1/2 squared, which is equals to 1/4. So we're gonna add a fourth here and 1/4. So what do we get when we do 4 times a fourth? Isn't that a 1? And when we factor out this perfect square trinomial, I'm gonna get the 4 outside, square root of the first number, sine of the middle term, and the square root of this third number, in this case is 1/2. And that's gonna give us quantity squared, and then this is gonna give me 4, the 4's cancel, and I'm gonna have -3 minus 1, which is gonna be a -4. Now here the vertex has to be exactly as the one we got in the previous way we did it. So in this case, 1/2 comma -4. If you scroll up your notes, we get the same. Okay. Now let's move to the next page and use all this information that we got from the previous page to graph this parabola. So number 1, our vertex, we got, okay, let's look at it again. That's 1/2 comma -4. In this case, well, it's our grid is divided into 1, so I'm gonna go in right in the middle. So it's gonna be 1/2 -4. So that's where the vertex is. The x-intercept, remember that we got the intercept using using decimals. So it's going to be -0.5 and 1.5, both with y-coordinate of y equals 0. So -0.5 and 1.5, which is right here. The y-intercept turns out being 0, -3. If you look at the notes in the previous page, y-intercept 0, -3. So by symmetry, let me add another number, I guess, somewhere here. So I'm going to draw this parabola using these properties. Okay, it's not going to be a perfect drawing. And let's trace the axis of symmetry here using a dashed line passing through the x value of the vertex. And that's our graph. State the domain and range. So what did we say about the domain? So domain, all real numbers. That is -infinity to +infinity, fancy notation, x such that x belongs to the set of all real numbers. For the range, in this case, it's going to go from the lowest value of the parabola, which is the vertex. That's a -1/2, comma 4. That's the vertex. And then in this case, it's going to go from this value all the way up, including that, the y value, all the way up to infinity. Using its set notation, y such that y is greater than or equal 4. Intervals in which the function is decreasing, and should have say increasing here. There's a little typo. Okay, so decreasing. I believe there was another typo on the other one. and most likely there's a typo on the next one. Decreasing and increasing. So it's decreasing coming from negative infinity, and when it reaches the x value of the vertex, that is negative 1/2, without touching it, and then increases again, goes up. So it's decreasing, goes down, and then goes up, increasing starting at negative 1/2, excluding the value negative 1/2, all the way up to infinity. Now let's see. So this finishes this example. Now let's look at another example. A very similar example, and this one is going to be a little bit different. So let's identify a equals negative 3, b equals 8, and c equals to 2. Now will this parabola open up or down? In this case, look at the sign of the leading coefficient, which is negative, so this is going to be opening down. For that reason, we are going to have a maximum, and in this case, concave down. Okay, concave down. How do we know the answers to B and C? Because A is a smaller, it's a negative number, or A is less than 0. That's another way to say negative number. Now, determine the vertex of this parabola. So x equals minus b over 2a, that's the vertex formula. So minus b, which is 8, over 2 times a, which is negative 3, which is going to give us positive 8 over 6, which reduces to 4/3. So our vertex is going to have an x coordinate of 4/3. Now we need to find the y value by plugging in the original equation, the original function, which is f of 4/3 equals to negative 3 times 4/3 squared plus 8 times 4/3 plus 2. So in this case, I will use a calculator to show you how I got this answer. So in this case, I'm going to get 22/3. Okay, let me start up my calculator. So I'm going to go negative 3 times 4/3, close parentheses, raised to the second, and then plus 8 times 4/3 plus 2. So I'm going to click enter, and I'm going to get a decimal notice. I'm going to get this decimal. In this case, I'm going to go click math, and then the first function that is highlighted is the frac, to turn that into a fraction, and then click enter twice to get that 22/3. So I'm going to write this using decimals, because we are going to need this when we graph using all these properties. All right. So the axis of symmetry is x equals 4/3. Again, that comes from the x value of the vertex. Find the x-intercept, and this is where it's going to get a little bit interesting. So negative 3x squared plus 8x plus 2 equals 0. Set that equal to 0. Okay, my advice here, every time you have quadratic equations, try to have the leading coefficient to be a positive number. To get that, divide both sides by -1 in order to change the sign of everything. 3x squared minus 8x minus 2, and that equals to 0. Okay, so we are going to look for a good method to solve that equation. And if you are breaking your head trying to factor this one out, 3 times a -2, let's see if it's factorable. So that's a -6 and -8. Are there any factors of -6 that add up to -8? Well, 6 is 6 times 1, 6 times -1. What I mean, 6 minus 1 is going to give us a 5. And -6 plus 1 is not, well, no combinations of factors of 6 are going to give us 8. The other possibility is 3 times 2, but also 3 times 2, 3 times -2, that's going to give us +1, and so it's not going to work. So in this case, we are going to use the quadratic formula. Okay, so we're going to go x equals minus b plus minus the square root of b squared minus 4ac, and divide everything by 2 times a. So putting the numbers, b is -8. Keep in mind that we changed the signs by dividing by -1. So -8, it's going to turn into a positive using the smile rule. And then -8 squared minus 4 times a, which is 3, times c, which is -2. Divide the whole thing by 2a, which is 2 times 3. I'm going to continue over here. Okay, so I'm going to indicate with an arrow that I'm continuing here. And I'm going to get x equals +8. Again, smile, be positive. Okay, and plus minus the square root of -8 squared, which is +64, and negative times a negative, which is positive. 4 times 3, which is 12, and times 2, which is 24. So 64 plus 24, what are we going to get here? Then divide by 6. So I'm going to get x plus or minus square root of 88 divided by 6. Well, in this case, we are not going to get nice numbers. All right, so I'm going to split this into x1 to have you know, let's see. I'm going to factor out, okay, forget the x1. So 8 plus minus the square root of 4 times 22. I'm breaking this down as 4 times 22 so that I can simplify the radicals a little bit. 4 times 22 is 88. The square root of 4 equals 2 root of 22 over 6. So x1 equals 8 minus 2 root of 22 over 6, which is approximately -0.23, and x2 equals 8 plus 2 times the square root of 22 divided by 6, which is approximately 2.90. You will get that using graphing calculator. So now we need to express this using x-intercept using order pairs. So the first x-intercept will be 8 minus 2 root of 22 over 6, which can also be simplified a little bit by factoring a 2, but we can leave it like this. Well, actually no, I'd rather simplify this. Okay, I'm going to do it on a separate piece of paper, so because I'm going to run out of space here. So I'm going to have 8 plus 2 root of 22 over 6. So I'm going to factor out a 2. I'm going to get 4 plus square root of 22 and divide by 6. 2 and 6 go 1 and 3. So it's going to be 4 plus root of 22 over 3. So that's the exact solution. So rather than using this, I'm going to erase this. So 2 minus, in this case is 4, and divided by 3, comma 0, and the same but with the positive, 4 plus square root of 22 over 3, comma 0. Again, we are going to be in the need of changing this to decimal form, that is negative 0.23, comma 0, and 2.90, almost 3 pretty much, comma 0. Okay, so again, it's going to depend on the type of answers the homework is asking you to submit. Exact answers, then you will need to submit these types of answers. Otherwise, decimal approximations by 2 decimal places or 1 decimal place, depending on what's on the blue letters on the homework exercises. All right, so to find what y-intercept is, evaluate the function at x equals 0. So negative 3 times 0 squared plus 8 times 0 plus 2. That's going to give us, 2. So the y-intercept is 0, 2. Now, in this example, for writing the equation in vertex form, notice how the process over here for getting the equation into vertex form could be a little bit painful when completing the square. So let me show you also in a different piece of paper. Let me show you the following. So one thing to keep in mind is that ax squared plus, maybe a better color here, okay, ax squared plus bx plus c, that becomes ax minus h squared plus k. One thing to notice here is that this a is exactly the same a as over here. All right, the only thing that changes is the h and k. So for example, let's see, let me make some more room here. When writing this, f of x equals negative 3x squared plus 8x plus 2. I'm going to write it using vertex form. In this case, the a is the same, negative 3, x minus number squared plus some k. What was the vertex when we got it from the top of the page? Well, we got 4/3, 22/3. 4/3 plus 22/3. Of course, if you want to do it the painful way, let me just give you a little. You will need to factor out the negative 3 here from the first 2 terms, but it's going to get a little bit crazy. X squared. Well, number one, I factored out the negative, so I need to change the sign of this. So plus 8 over 3x. Okay, and then plus 2. So when we get that magical number that completes the square, look how ugly this is going to be. So this will be 8/3 times a half squared. So this will be 8 over 6 squared, which is, well, actually 4/3 quantity squared, which is going to be an ugly number. That's 16 over 9. 16 over 9. 16 over 9. Okay, 16 over 9 at 9, so 2 times 9. Oh, that times negative 3. right? Because if I add a number, notice in this case the crazy thing is that I'm adding a negative number. So when I add a negative number, I must add this time the number. So it's gonna get crazy. You should get the same thing still, all right? However, I wouldn't recommend you to do this. So I'm gonna stop here for this part of the problem, and I will let you complete it on your own. You should get the exact same equation here or form. All right, so now let's move on to the next page to graph the form, graph the equation using the property that we got from the previous page. So first of all, we are going to graph the vertex, which is 4/3, 22.3, which is 1/3, 7/3, 1.3, 7.3. So 1.3 somewhere here, and 7.3 somewhere here. All right, somewhere there. And then we have the x-intercepts at negative 0.23 and 2.9. Negative 0.23. Well, this one is going to be a tricky one to graph. So it's not even half. It's somewhere here. And 2.9, which is basically 3. Almost 3, but not quite. Somewhere here. And then we have a y-intercept at 0,2. At 0,2 we have the y-intercept. And then I'm gonna graph this parabola. Notice in this case it goes with all the ideas that we got from the previous page. Opens down, has a max, and it's concave down. And then let me trace the axis of symmetry. State the domain and the range. Stating the domain and the range, the domain, again, it's all real numbers, negative infinity to positive infinity. Fancy notation, x such that x belongs to all real numbers. State the intervals in which the function, range. So the range of this function now, it comes from negative infinity and goes all the way up to the y value of the vertex. Okay, let's recall that this is for 4/3, 22/3. So in this case, it's going to go from negative infinity to 22/3, including the 22/3, using fancy looking notation. Set notation y such that y is less than or equal 22/3, because it's all the y values that are below 22/3. State the intervals in which the function is decreasing and increasing. Yep. So decreasing and increasing. Decreasing and increasing. So decreasing, it's going down over here within this interval, starting at 4/3 and on, excluding the 4/3. And in this case, it's negative infinity. It's increasing from negative infinity to 4/3. All right. And this finishes the examples of graphing functions using the properties. Now, let's find a quadratic function given its vertex and another point. All right, how are we going to solve this problem? Well, let's see and let's have a look. So number one, keep in mind this form f of x, the vertex form. Oops, I forgot multiplying by a, and then plus k. So the first thing we do is to plug in the values of the vertex. Okay, so that's the first thing we do. So f of x, f of actually when x is 2, y will be 1. So x minus, wait a minute, we're not actually plugging in for x or y. We're actually plugging in for h and k. Okay, let's omit this part. Okay, so we're gonna have, I'm gonna start with y equals a x minus h squared plus k. So in this case, h equals 2 and k equals 1. So y equals a times x minus h, which is 2, and k, which is 1. I know what you might be thinking, expand this binomial here. However, that won't be necessary, because now what we need to find is what the value of a is. So in this case, we are going to use the point 0, 5 to find a. All right, so y, which in this case our y is 5, equals to a times x, which is 0, minus 2, quantity squared plus 1. So 5 equals some a times negative 2 squared plus 1. So negative 2 squared is 4 times a, that's 4a. Plus 1 equals 5. And I'm going to solve this baby equation for a. So I'm going to subtract 1 to both sides to get 4a equals 4, and divide both sides by 4 to get a equals 1. So the equation or the function that describes the given parabola as a graph will be f of x equals a, which is 1. I'm not going to write the number 1, x minus 2 squared plus 1. So that's final answer. So keep in mind there is an invisible a equals 1 here that we don't need to write, but I'm going to write it just so you can see. Okay, and a couple of more problems finding the maximum value of a quadratic equation. So determine whether the quadratic function right here, it's going to have a max or a min, and then find it. So this is nothing new except for the wording of the question. So in this case, to determine whether it has a max or a min, well, we'll look at the sign of the leading term. In this case, it's going to be a minimum because a is a number that is greater than 0 or is positive. So let's find that. So minus b over 2a. We use the vertex formula to get that, minus b over 2a, which is minus negative 4 over 2 times 1. So that's going to be positive 4 over 2, which is 2. And then we get the maximum value by evaluating the original function, on the value that we got for x. So that's 2 squared minus 4 times 2 minus 5. That's going to give us 4 minus 8 minus 5. So 4 minus 8 is negative 4 minus 5. That's equals to negative 9. That is the minimum value. Okay. Now we're gonna have another example here in which we have an application projectile motion given by this equation. If you look at this, rather the function of a parabola, which I'm gonna rewrite here because I will simplify this. So in this case, 32 over 100 squared, that simplifies to negative 2 over 625. This number right here, x squared plus x. Number one, are we going to have a max or a min? Well, in this case, they're telling it us in the problem. Find the maximum. So at what horizontal distance is it's the projectile at its maximum height? And we can tell by the sign of the leading term, which is negative. That's going to give us an upside down parabola. Okay, so the projectile it's gonna go up, and then it's gonna go down, reach the max, and then go down. Up, max, down. So let's find the value of x, or the distance x, at which the projectile reaches its maximum height. So in this case, what's b? B is 1, so minus 1 over 2 times a. In this case, a is negative 2 over 625. Okay, so in this case, dividing by a fraction is the same as multiplying by the reciprocal. And in this case, notice, let me erase this negative sign. We don't need it anymore, because negative times a negative is going to be positive. So we get 625 over 4. But in this case, 625 over, let's see, did I forget anything? No, 625 over 4, which is approximately 156.25 feet. So again, it's going to depend on the homework if they want reduced fractions or decimals. Well, for this type of problems that have a physical context and something like this, most likely you will need decimals as final answers. Okay, so let's find the maximum height by evaluating this at 625. Negative f of actually 625. I'm going to use the exact form, because with the decimals a lot of values are going to go away. I'm afraid of that. So minus 2 over 625 times the x value squared, which is 625 over 4 squared, plus x, which is 625 over 4. I know this is going to be a little bit scary because of the numbers, how large they are. 2 over 625 times 625 squared. I'm not going to do 625 squared, but I'm going to do 4 squared, which is 16. And the reason for which I'm not going to do 625 squared is because I can cancel 1 with denominator, plus 625 over 4. So I'm going to have 2 over 16, which reduces to 8th. I'm going to have negative 625 over 8th plus 625 over 4. If you use a calculator to simplify this, you are going to get 625 over 8th, which is approximately 78.125 feet. And again, it's going to depend on the number of decimal places. Sometimes it might be 2 decimal places, sometimes it might be, notice here I simplified to 2 decimal places. Over here I'm going to do the same, 78.13 feet. So depending again on the instructions that are in blue every time you see a problem like this in the homework. Alright, so this example covers wraps up the entire section. I'll see you on the next video.